Max. Yeah, I know. Nobody wants to sit on the front chairs. Thank you guys for coming. And most importantly, thank you, Maxime, for hosting us and Google for hosting us. I'll quickly start with we've been doing these meetups. This is the second meetup. The first one we did was in San Francisco with the Slack IR team presenting. The goal we started meetups was we did realized that within Bay Area, at least, there was no forum for incident response and forensics people where they're meeting and formally sharing knowledge and stuff. I learned that there is at least one more forum which supposedly closed. You need to know somebody to get into that group. But that was the goal. I'll introduce myself and then we'll have Maxime introduce as well. I'm Rishi Bhargav, co-founder of Demisto. We are focusing on incident response and automation. Basically, we are a startup and the goal is really how do you make the life of an incident response analyst easy? Because there's so many manual tasks that you still need to do, even with all of the open source tools which are doing the security data collection, but the process, the documentation, the collaboration, and all of that. Enough about Demisto. And I think, again, towards that goal of making life easy, one thing we want to do is let people talk, interact, share knowledge. For that, we have this meetup, and then I'll put in notes. We also have a Slack community, and that Slack community is, again, incident response analysts and security analysts sharing information, open to anybody to join. And it's all, again, sharing knowledge with each other. So I'll post in the notes if you guys want to join as well. Maxime, you want to introduce yourself, and then we'll quickly go through the agenda.
Sounds good, thanks. So Maxime Lamothe-Brassard, you can pronounce it Max, you can say Maxime Lamothe-Brassard, you can say whatever you want, it's all good. I'm used to it. Yeah, I mean, I've worked in security for a pretty long time now. Really, most of my career has always been kind of around APT in one form or another. So it's a part of security, which is a very large landscape. I worked for government for several years, so in the intelligence community. Worked for CrowdStrike and worked for Arcadia as a startup, and now I'm currently an security engineer at Google. Yeah.
And we're going to talk about Lima Charlie. So
that's right.
I think quickly, the one call for speakers, and we will do that towards the end as well. So I love to hear about projects that you guys have been working internally, best practices, different topics, but we always do it as a very interactive manner. So today what we're going to do is we're going to go through some Q&A, which is kind of at least questions I thought we should ask Max about Lima Charlie, which is his project, open source project, but then let's make it interactive. And then he's going to do a live demo as well after that of the tool and how it helps analysts. So question one, I think, what's Lima Charlie and why did you start? I think among all the other projects, what's this project about?
So Lima Charlie is, and I'm sorry, it's unavoidable. I will be using what some consider buzz terms. But at the end of the day, we need common terms in the industry, and sometimes they're buzz terms. So it's endpoint, meaning it's a project that aims at providing security at the endpoints, not at the network layer, but really on all of the endpoint devices. That's at a very high level. I started Lima Charlie because there's a lot of security products, more and more into the endpoint space, much more even in the network space. I mean, I think traditionally, security has always been really network based.
Yep.
Clearly, it's becoming more and more difficult as things like TLS, everything becomes encrypted, and now you get a bit blind on the network. So what I wanted to do was to really help make more presence, more detection on the endpoint, and to do it in a way that that I've had success in the past with. So there's a lot of products out there, and the devil's always in the details, right? In terms of endpoint is not endpoint. There's tons of other products, and I'm sure we'll get on the topic. Yep. They always come up. And each one has kind of a different perspective on the problem set and a different way of approaching it. They all have, in my opinion, very good strengths. And I think that Lima Charlie kind of fills one of those niche, which is the niche of constant monitoring. So not so much the burst complete visibility, that the classic, like, we'll unhook the computer and image the box and do all these things. But really, what do you do and how do you have visibility on your entire infrastructure, all your platforms, and you do security monitoring on them? And how, as analysts, do we actually get, are we able to influence it, right?
So before we get into the technical details, what's the meaning behind Lima Charlie? Is it the military meaning? Is it more than that?
I think it's kind of a mix, right? So there is the NATO Lima Charlie for loud and clear, which is on the radio, meaning essentially I acknowledge, I perceive, I understand. It's also a bit of an inside joke with much of the architecture was actually developed while I worked remotely, and I worked every day in the morning from a coffee shop that was called Café LC, so LC. So it was kind of a way for me to.
That's interesting. So getting deeper, so you mentioned there's gaps that you found in the endpoint product. So again, one of the questions is obvious, which is like, what is the design philosophy? What gaps? And what are you like? I think one of the challenge which every other product has, not just open source or commercial, is like to really get to an adoption level, you need to find, say, this is what I really believe in, and this is, so what's the core of the
core? I think the core philosophy of it is that I'll paraphrase a little bit to really explain it better. In my experience, when you are monitoring a network, right, for different threats, and you're the person responsible for investigating what might come up, and then you have to go and investigate, and then maybe like fix the issue, kick the bad guys out. Really, one thing that really always comes back is the friction in that process. And so the core philosophy is to reduce the friction. What I mean by friction is you're sitting at your desk and you see some alert, right? It's kind of the most basic interaction with a system like that. The question is, how much time does it take you to turn around and go and investigate this? And investigate doesn't mean, oh, I'll look at the data that I receive, because that's not enough. It's never enough. It's about seeing what I've received, understanding what else I need, and then to keep going. Because if it takes you an hour to investigate something, my personal experience, I think it's human nature, is you're going to go and you're going to look at it and you're going to go, yeah, it doesn't look that bad. I got a lot of other stuff to do, so I'm sure it's fine, right? Or it looks kind of shady, but I don't have any of the other data. It's going to take me 4 hours to task it and do all of these things. Like, yeah, it should be okay. Or if I see 20 other signals, right, coming about that box, then maybe I'll have a look at it. When in reality, when you're looking in particular at APTs, right, like the concept of like, I have 20 signals, so it's worse than if I got one is not such a good logic.
Very true. Okay.
So there's that friction, and then there's the other side of the friction. So that's very much kind of the operational aspect. The other side is endpoint detection is still so early on. There's a lot of companies that do really good stuff, but the reality is, just let's, 5 of us will sit down and we will spend 5 hours just discussing ways in which we could design something to go and detect stuff.
True.
And that, 5 hours if you're lucky, right? So there's so much to be done. There's so much to be tried. There's so much that the community can get together and somebody try it. Maybe it's not working somewhere. Maybe it's working somewhere
else. And then 5 hours later, it'll be old already because there's an attack which bypasses.
Exactly. So if you're sitting at your desk and you're saying, I have this great idea. What if, I'm going to pick an example, right, that I've lived, right? what would happen if there's a module, so like a DLL loaded in a process that is not a .dll? And then you're naively thinking, right? Maybe you know, maybe you don't know. You say, yeah, that might be an interesting detection. If to go from that to proving it, it takes you a day of development and then deployment and all that. Then again, same thing. You're going to sit at your desk and go, yeah, maybe it's bad. I'm going to, Google search. Yeah, I'm not really finding anything about that. Okay, no, I'll go to a sure bet, right? Something I know will work. So it's about reducing, again, that friction.
So if I were to rephrase it, I think one of the crux of the value you said is you can design your detections very quickly and try them. And do you try them live or do you try them historically or both? Or
I think the idea is to give you the tools to get a better idea historically if there is the data. But ultimately, depending on what you're looking for, there's nothing quite like live data. So one of my objectives was very much to be able to, quickly on your box, prototype it, essentially dump that piece of logic into some black box that will run the processing. After an hour, maybe you've DOS'd your own box, and that's okay. Now you know, right? You can refine your detection, and that's how you learn. Or maybe you got nothing, in which case it's not necessarily a bad thing. Now I'm not going to generate a lot of false positives. Maybe I'm never going to detect this weirdness, right. But maybe in 2 years that'll be the one thing that'll pull me to the APT.
So we talked. You mentioned earlier more specific tools. So there's commercial tools, but then there is other open source tools. I think I understand the difference, but it'll be good to talk to the team. And guys, if you have questions, please ask away. Is tools like GRR versus OSX Collector, OS Query, and those I also categorize them as IR endpoint tools. How do you think Lima Charlie, where does it start? Where does it stop? Where do these other tools have their boundaries?
It's a blurry line, right? I mean, it's a spectrum, clearly. I think the biggest difference, it goes back to, I think, some of the first few sentences, was the idea that the devil's in the details in terms of kind of the operational spin that you have on things. So a lot of tools, for example, GRR, are really forensic centric, right? So you're saying, I want to go on this box and I want every single possible timestamp from the low-level file system, and I want to dump a whole whack of data because I think I got some other signal that told me there's something bad. And that's kind of the bursty side of things, I think. Lima Charlie would be towards the other end of the spectrum. So the idea of Lima Charlie is not to burst. In fact, it's kind of through the philosophy of Lima Charlie that everything pretty much always runs at all times. So the idea is constant detection. To give you a very basic example, GER would be able to go and look for hidden modules in memory. So a module that's in memory, it's not listed by the operating system, but it's executing there. Absolutely, the capability is there. Where, again, it's in the details is that because of the philosophy of Lima Charlie is just constantly at all times slowly crawling through the system, through all of memory, all user mode memory, looking for hidden modules. So is it going to catch it the immediate second, a straight hook from the kernel that there's a new module that's hidden that got injected? No, that's not the game when you're talking APT, right? So it's kind of the constant detection, the constant generation of telemetry. So we generate a lot of telemetry that some of it goes back to the back end, some of it doesn't. But it's always being generated as events occur and you react.
Got it. So I think those are all the questions I had, other than the directionally, but yes.
So with Go, when you do any kind of memory dumping, it does it brings about performance, it makes the laptop or any kind of host machine kind of unuseful for a while.
Yeah, that's right.
With Lima Charlie, essentially trying to do what Go does on a very operational and continuous basis. Like what kind of like performance dips are you seeing on the host machines? Like from a security perspective, it's fine that we have this kind of like continuous monitoring, but on the user side, it's
of course not.
Exactly.
Yeah.
Oh yeah.
It's like why?
The last thing you want is like people complaining, saying like your tools are making me not
Exactly. I think that's the constant is like security is good.
System, if it's
User doesn't use it, it's the most secure system.
Yeah, you've hit the nail on the head, right? That's the biggest difficulty in all this. The way that it's not sidestep, because I mean it's a real problem. It's a physical issue, right? The way that you kind of get around it is by trying to look at it slightly differently, right? So if you're looking, let's say in deep forensic land, I want to dump the entire, I want to dump this process memory, potentially hundreds of megabytes, right? That you're going to be generating, and dumping all of that's going to have performance issues. The idea is in Lima Charlie, although, I mean, we could, it's software, we could dump it like that, but like you're saying, we'd have an impact. What we would do is we really target what we're looking for. So I've never dumped a process's entire memory from Lima Charlie, not because it's not good, but because that's my goal by operating this is not to generate kind of the big forensic case all at once, but rather really investigating to the point where I know there's a bad guy on this box and here is his footprint, and here's how he does his thing, and then maybe we will go and use GER to like forensically image the entire box and do the expensive stuff. So in terms of the memory, right, the hidden module detection, it's as simple as saying I accept that I'm not going to look for the hidden modules of the entire system within 10 minutes, right? So what I'm saying is I will look page per page through memory, and I will throttle myself so that the user doesn't become aware of it. So a lot of the testing with Lima Charlie is actually developing this, this collector, internally known as a collector, right? I have one to detect process hollowing. It is very expensive. And so developing it, you develop it, you run it once, you spike the hell out of the box. Then it's a question of, okay, conceptually, if I accept that looking for process hollowing in a single process will take me an hour, where do I start unraveling that loop and make the loop really not a loop anymore, but just like constant throughout the entire day? I'm looking in every process for a hollowed process or hidden modules or code injection. So just very slowly going through everything. So it's a very interesting debate, and I know I always have it every time.
So just to repeat the question, because this is on Hangout, the question was what privilege this thing's run at?
So Lima Charlie technically can run as a normal user. That'd be quite a dumb move. It's really
gets nothing, finds nothing.
Exactly, but it is really safe. It's really realistically designed to run a system. So with all privilege, but, and here's the debatable, and then that's a debate I love because I'm not completely one-sided, is it's user mode. So currently Lima Charlie is 100% user mode. Pros and cons. Pro, I will never, ever, ever, ever blue screen a box. Well, except on OS X, but that's a different thing. The con obviously is some, one might argue less visibility. In my experience, 99% of stuff, even the badass, kernel mode rootkits, end up because of the same difficulties going user mode, and we end up catching them in user mode. The real point is it's much more difficult to get essentially push event notification, right? So for example, in Windows, if you're in kernel, you get direct notification of a process starting. It's very efficient. In user mode, you're much, much less efficient. So it's trade-offs. I've been for a long time eyeing the idea of having a kernel mode component, but it's strangely, it's actually the pendulum in some ways is going the other way. Because of all the security measures in modern operating systems, it means that for an open source project to want to have a kernel presence, it's not impossible, it's just a pain in the ass in terms of signing and everything that goes along with it.
So how do you get those processes that start and so on? Is it Windows event tracing or things like that?
No, so every event has different techniques in different operating systems. So an example, in Windows, doing brute force-ish process diffing through the Windows API, incredibly efficient. Doing that in OS X, it's orders of magnitudes less efficient. So that's where Lima Charlie is cross-platform, in the sense that it abstracts the platform. Obviously, you need some specific code here and there, but there's certain, really at the end of the day, it comes down to heuristics in terms of how you do sometimes the diffing or the notification in certain, doing OS X file notification is difficult. Windows, trivial. So it's different things like that.
So to follow up on the question, if you just dump the memory of the process, you can sort out what to do with it later. But if you do your kind of skull scanning, you have to be more precise what you're looking for. So how do you solve this problem of knowing exactly what to look for and then changing it as you need to look for more things?
That's an interesting question. So I don't think yeah, in a way I see what you mean, that you need to be more precise. But I'm not sure if that's actually completely true. And it's always taken that I'm really looking at this from the APT perspective, so not so much as the AV. In terms of, if I'm looking for something very precise, and I know exactly what I want, I will write a Yara signature, right? Yeah. And again, going with the philosophy, the way it works is you push a big Yara signature blob to Lima Charlie, and Lima Charlie just constantly looks for it on disk and things loading, as well as in memory, crawling memory. So if I'm looking for something very precise, if I'm not, picking the example of the dumping memory, usually the way that dumping memory will come into the picture will be more around, and we'll get into that, but around the idea of I'm looking, I'm looking for hollowed process on the box. And at some point, I do detect a hollowed process in a specific process space. And that will generate the detection. The sensor is kind of pub sub internally. So I might have secondary collectors that are waiting for that. But I'm also, in a way, pub sub with the cloud, where, sorry again, the cloud, the backend. So essentially, in the back end, I will have hunters, which are essentially, a Python piece of logic, again, to reduce friction, that might be listening for that. And he's going to say, oh, I just got a hollowed process at this address. Okay, I know how to investigate that. And part of it is go dump 100 kilobytes of memory starting at that address, or get me, the strings found within that chunk of memory.
So then some of the brain power is on the server side.
Exactly. Exactly. You can absolutely deploy on the sensor side logic. Obviously, it's always the barrier of entry to do that is much higher. It's more difficult, performance reasons.
So then how do you manage trust between the endpoint and the server if you're going to be executing arbitrary code passed down?
Ish, but yeah, no, I totally know what you mean. I say arbitrary just because we're not sending actual executable code, right? It's within the tasking framework. So the way trust is built is there's 3 main levels of trust. So the sensor itself is only takes care of comms and crypto, is sitting on the host. Again, reducing friction. The idea is I don't want to have to push an SCCM job to update my stuff because I have to involve 20 different groups and nightmare. So essentially, the security component of the sensor gets streamed down to the sensor on the box when it starts. So there is one level of trust there in terms of the signature of that blob, that executable code. The cloud doesn't have it. It's pre-signed blob that we generate in the cloud. We keep the keys in a safe. The second level is between the cloud and the sensor, the comms that it does, right? So there we have public-private keys. We're not using root CAs, so essentially it's pinned onto certificates. And the cloud is therefore able to do very, very, very basic tasking of the sensor. Usually it's around update your clock to, essentially kind of NTP type stuff, just sync clocks, or set your next, your next beacon to in, 60 seconds or things like that. So that's one level of trust. And then the third one is actual tasking, which is more dangerous. The architecture was designed such that if you want, you can not have that last level of trust in your cloud at all. So for a long time, I ran one particular client's infrastructure with that key being kept on an offline box and a hardware USB key, right? So that if an attacker gets in the cloud, there's very, very, very little he can actually do. Now, obviously, if you do want to do that kind of tasking around, then it's a question of managing that risk, right? So specific actors in the cloud will have access to that key, and they're gating, they're not giving access to the key to other actors, they're gating the tasking by saying, these actors are allowed to do these tasks on these hosts.
So actors are humans on a box, or actors are hunting scripts, or actors are...
Good question. Actors are the way that the backend is shaped. So the backend runs mainly on Beach, which is, if you know Cassandra, which is NoSQL storage. The idea is, horizontally scalable, no single point of failure. You take that concept and you adapt it to computing. So it's kind of like that. So it's a peer-to-peer nodes that run Python actors that have a way to resolve messaging and load balancing and everything between each other. So an actor runs in the cloud in that way. When you create a detection, you'll create an actor that implements that detection.
So one question I have is, with all of these pieces, the endpoint and the server, how do you get started? If you want to use it, is it deploying separately, or do you deploy from the server as well? Or what does it mean for somebody to get started and use?
Yeah, it's a good question. It's one of those rabbit holes, right? So it's like saying, how do I get started with a load balanced web server on Cassandra? There's a lot of different ways to get started. There's some that are much more costly than others. The best way, in my mind, to get started, really just from a trying it perspective, is to run what I call the cloud in a can, which is essentially in the repo, and that's how all the tests internally are run. You can install you get a Ubuntu server, beefy enough to your needs. And essentially you do a checkout of the Git repo, and you have one script to execute. And that script will download all the dependencies. It will install Cassandra single node cluster locally. It will install Beach single node cluster locally. Load all of the basic actors that you need to do all the the keeping the lights on, as well as the current head of detection actors. Pardon?
Some of the logic will come with it too, right? Some of the detection logic.
Absolutely. So it's checked in specific parts of the repo, and so it loads it all up for you. Now, you probably don't want to do that for your large company because, well, first it's a single node, so that's really not the point. The second one is it's using at the moment just default keys. So it's really, I just want, I have 5 hours today. It's Friday afternoon. Whatever, I just want to try it. So you get it installed on that server. There's pre-built binaries for the sensors for Ubuntu, OS X, and Windows. Windows 32, 64-bit. You can do your own builds, but no fun. So you can drop that sensor, run as administrator. So not even a system administrator will run fine. And as long as you point it to the predefined DNS, so you can put in your host file, point it to the server, and it just starts up. It starts up all the web UIs and everything that goes with it.
And so, good question. There was the logic. So you said it comes with some of the detection logic. Writing detection logic, I thought you mentioned was Python. Now, how much understanding does somebody need to have to kind of understand all the actors and other pieces as well to go? Like, what's the skill set you're expecting?
Yeah, that part is simple. There's three different kinds of detection, right? So the way that I'd say it links with the question about how you start, right? Is when you start, you see events coming in, you see what's coming in by default from your sensor, the data, and you might get some ideas from that. You can look at the detections that are in there as well to kind of get some ideas. The three main ones is stateless detection, which is a tiny piece I'll show you during the demo.
Okay.
Tiny piece of Python logic, single, process function that receives one message. It's stateless, meaning it's designed to not really interface with other things. It's really great for the simple stuff. For example, it's a subset of an example that's already in a repo, but if something executes from the recycler bin, it's going to be bad. Well, I can look for that by looking at process execution, and then I do, if recycler is in the path of the executable, bang, generate a detect, right? So that's simplest. Then we have stateful detections, which are slightly more complex. It's the whole topic of itself, how to do efficient stateful detection. But essentially, they're tiny kind of Python classes you put together in kind of a very simple DSL, and you do things like, well, if I see 3 processes coming from this, this module executing in 10 seconds, then generate the detect, right? Pick the simplest example. But you can integrate all kinds of correlation between those. So you can say, if I see the sensor start, and then I see a process starting after that within 5 seconds, and then I see the sensor shut down, then I don't know, maybe I think that's weird. So I want to generate the detector. So you do that. The last one is the hunters, which is kind of one level higher than that. So now what you're doing is essentially you're codifying much more advanced logic, and you're gaining access to a lot of the modeling that's done in the back end of Lima Charlie. So Lima Charlie does a lot of modeling on things that we call objects. So normalization of everything that's coming back from the sensor, so that you can do some interesting advanced queries, which I'll show you. But the advantage is now you have a class that will get updated for an investigation. When a new piece of data comes back from an investigation or a detect gets triggered, and it has access to all of the backend models. So to pick an example, again, I'll show a bit.
Maybe if that's better, we can start with the demo unless people have other questions, because these are probably getting into the depth. Other questions, or we can take the questions during the demo as well.
Absolutely.
Okay, cool. Let's turn that on.
Okay. So you have the resolution working well.
We need your figure out the resolution piece. You want to use another table, Maxime?
No, I think I'll go on the size there.
You pray to the demo gods?
Create the demo guards and the screen guards, which
Demos never work out, and that's okay. So I kept it pretty simple. So
demos don't work out just because of VMware. My theory is like you try to put all of them on a VM.
And keep in mind that in this case, the entire demo is running from the laptop. So the laptop is running Windows 10, running Visual Studio, running the sensor with Ubuntu, running Cassandra, running the whole freaking stack. All right. Well, thank you. I wonder how far that thing goes. Not very far. All right. So first step is looking here. Yeah, everything's running. So what we're seeing here, very basic. So caveat, I am not a UI developer. It's funny, some people were talking about UX before. I'm sorry. And that's why I'm excited to see kind of actually products like we might say later at the Demisto that kind of take care of that stuff for me. I know my strengths and my weaknesses.
To the demo, hopefully
that'll be good. So that being said, a system without a UI is just not very useful. So this is the current web UI for it. One of the main views, so what you're seeing now is really simple view of one sensor. All of the events, what's happening, you see, here's a code identity event, which gets generated for every unique piece of code that gets loaded on a host. So we don't exfil the same one over and over again, but we boil it down with basic information about the cert, where it is, all these different things. Process starting, beacons terminating process, all that stuff. What we get back to the cloud is a subset of what gets generated. So we generate a whole lot of data on the sensor itself. For example, all file creation is logged always on the sensor. We don't always bring it back. But because it's all pub/sub, it means that it's really, really trivial for somebody for a hunter, for example, to go in and request it. So I'll show that. But what you're seeing here is just a shortcut to the last instance of every one of those events. So you can see there's quite a few events. Some of them are, file delete, so they're very basic telemetry. Some of them will be hidden module detected, so that's also an event. And we could jump to it. Obviously, the scales are kind of messed up here, but that's okay. So we can filter, see the full, the full timeline of everything that came back in the sensor. It all gets stored. We can also see what I alluded to a little bit earlier, the idea of objects, right? So when a message comes in, what we do is the intake. Yeah, we always down at that end, that's simple. But we also track kind of every piece of some like call them IOC, although in this case it's not really compromised. But we extract objects in the generic form. And we store them in a pretty vivid way where we're able to tell some interesting things from it. So in this case, I'm going to go and say, show me all of the module objects that I've ever seen on this host. So, okay, we get just a big dump. You can see those are object module names. Nothing too crazy. I will go and I will pick one at random and hopefully it does a good job. Okay, so here I picked Google update.exe. So now what I did is I'm changing my perspective to that object. When we store the objects, we also store relationships, meaning if I saw a code identity for Google update.exe and it had a signature in the code identity, I'm going to store the idea of, hey, I've seen this module name, and I've seen this module name as a parent of this certificate issuer. So I'm going to keep a lot of those relations between objects. So the objects will be, module name, processes, paths, command lines, domains, IPs. You could, extend it as much as you want. Obviously, data is not free, so you might have to expend your storage for some of them. But we keep it, and then we keep the relationship. So now what I'm doing is I'm centering on that module name, and I'm saying, what are the children and parents that I see? Okay, that's interesting. So I see a cert issuer here. I see a file hash for it. But because I keep the relationships as objects themselves, it means that I can kind of start going meta on it and say, show me all of the hosts and the last time on these hosts where I have seen this module loaded within this process. That's of some interest, especially when you get into more advanced detection. You're saying, should WinINet.dll, WinINet.dll, that doesn't ring right. Is it? WinINet.dll. Should that be loaded in LSASS? I don't know. But with this, I can get instantaneous stats on it. I can say on the 50,000 hosts in my network, I've seen this relationship on 5 of them. Okay, interesting. You can also keep going and say, hey, I've seen this malware, and it's a process. It's called evil.exe, and I can see its children, all of its modules. So here we don't see it, but in most of them, when we do a snapshot, we would have seen all of the modules loaded within it. Well, now I can say, well, what if they change the name of that thing and the hash and the command line? How would I find it? It's kind of a tricky thing, right? It's not even the same path. Well, now you can start and say, okay, let's compute the statistical relationship between that exe and its modules, those relationships. Let's find the ones that are unique, that I haven't seen in anything else, and show me all other processes that are similar to it. Because if it's the same implant, it's likely going to import the same things, have the same modules. And so now you can start from one and really, without ever really doing reverse engineering, without even getting the binary, you might be just be looking at historical data. You can start expanding.
Wait, when you say keep, do you mean keep in the cloud or keep on the client? Because your client storage gets pretty fat, and that's where I'm dealing with it.
So that's kept in the cloud. So the way that it works is the backing of all of the scale storage is done by Cassandra. So good and bad, right? If you've done SQL versus no SQL, they're vastly different trade-offs. But it means that for stuff like that, it is great because it's kind of key value relationships, and you want to crawl between those relationships. It's just blazing.
But you have client storage like file creation, you said, so that gets pretty fat, right? How do you keep that?
Yes and no. So the clients, what the client will do is the sensor will keep a rolling buffer. So I think by default it's 10 megabytes, I want to say. So 10 megabytes, all of the events internally that get generated get stored in memory. So we do not store state on disk. Whole bunch of reasons for that. So we keep 10 megabytes of that rolling buffer in memory. And we have a tasking that is called history dump. So a lot of the hunters or detections on the cloud side, the first thing they'll do is they'll say, dump me your history. So you don't have to extract all the file creation all the time, but when you do, that sounds like a commercial. But when you do, you get all of them. At least the certain buffer, like 10 megabytes. If you're more resilient to more memory, then you can crank it up quite a bit. So one thing I will do is, and that's so we're entering the part of the demo that is possibly going to fail. So what I'm going to do is I'm just going to switch very briefly. And I've got a demo piece of malware. I know, it's just like a vendor. It's totally fake. Essentially, it's the source is in the repo. Malware demo 1. Going from memory, it's a .txt.exe with a false icon stamped on it. What it's going to do is when it executes, it's going to drop a text file, open the text file as if, oh, yeah, it is a text file after all. It's going to drop itself in the recycler, boot from the recycler, and inject a piece of code in a random process. So yeah, I wanted to, the shotgun approach to just hitting detect, right? I do believe that my paging actor is on. So if you have my phone, it might start buzzing. We'll see. All right, so I'm just gonna run it. It's Windows 10, so I'm gonna run it as admin just to be sure to hit it. There we go. Yeah, so the text file spawned in. If I look, yeah, it is a text file, no problem. I'm gonna go back to my sensor. It's buzzing, awesome. All right, so now I'm gonna look at my sensor and I'm gonna look at my detects view. So very similar view, except this is just the detect. So detects are not events from the sensor, they're generated by the cloud whatever, all these things I mentioned. So here we're saying Windows suspicious exec name from a code identity. We're getting another suspicious exec name from the process creation. And some of the others will probably kick in a little bit later when the code, the hidden module, is going through memory, and at some point hidden module will just spot it and go. So what happened in actuality, and yeah, there's going to be another wave of buzzing, I think, hopefully, which is due to the hunter. So I'll switch a little bit to, I apologize if you're not, if you don't know Python. It's a very basic Python. I'll go kind of quickly above it, but I think visually it's important to see what does detection look like? What does it mean to reduce the friction, right? So I will look at the one that just triggered. So Windows suspicious exec names. So is it big enough to read-ish? Yeah? Okay. So this is a stateless actor, a stateless detect. So what you see is when we initialize, we just generate two regular expressions. One that looks for some document extension, .exe. The other one that looks for left to right override. And then all we do when we actually process events, so that's kind of the entry point, is we take the message, we look at every file path in there, we apply it to regular expressions, and if we hit on something, then what we do is we generate the detect with that event. And we have the option, which is used here, to task that sensor. So you don't have to know which sensor, what's going on, where is it coming from. Stateless is as basic as it gets. So you just say, well, I should task back the, I don't know how to readable, but remain live for 60 seconds. So it's going to tell the sensor for the next minute, just keep just hitting me back because I need really that latency. It's already adjustable in general to whatever you want in your infrastructure, and it's smoothed out the traffic. Sorry, other topic. The next one is dump your history. So just give me everything you've got. And that might generate other detects. And then the last one is exfil add, notifications file create, and expire in 60 seconds. So I'm telling the sensor, okay, you dumped me what you had in the past, but for the next minute, I also want you to give me every file create as it happens. Start sending it back. So just basic stuff in a stateless detect. So that's really what stateless detection. To load it up, it's as simple as, you can script it and do it however you want, but it's, beach.add my actor. You can add 50 if you think that it's going to be expensive and you need to go through the traffic, and it's just live. If it doesn't work out, you can just wipe it out at runtime from the cloud. So a stateful, yeah, and I may not see you if you have a question. Like, yeah, sorry, go ahead. Yeah.
So while we were doing the history dump, is that going to just keep dumping? If you generate a bunch of detects, it's going to dump the history a whole bunch of times in a row, or?
It would be technically possible. When you dump history, you also flush it as you export, so you're not going to dump the 10 megabytes over.
Yeah.
That would be an interesting one, though, like some kind of loop, right? But yeah, no, good point, good point. Stateful, I'm going to go very quickly over because it's just getting performance out of stateful detection is very, very painful. But essentially, and this is kind of a simplistic view, but essentially it's a very simple DSL based on Python, where you have, SAM process descendants is kind of, I call them widgets. They're widgets that you kind of put together in a tree structure so that you can say, well, time correlation, processes called evil.exe and sensors going down event, right? And so you just plug them together, and now it's going to do the time correlation on the input events. It's a way of keeping some sanity from a development perspective, as well as getting some performance. Because if you're trying to do back detection always by going in your data store, you're just going to die. If you're trying to implement a real full state machine, you're never going to be able to code within it.
Where's the timer of any kind? I mean, you keep state, so presumably there's a timer somewhere. I don't see the timer.
Sorry, I don't know if I picked up one that has a timer. So this guy is a document exploit, right? Very basic. So I'm saying, this guy is saying, if you see these processes as descendants somewhere down the line of these processes. So if I see either iExplorer, Chrome, Firefox, when all those, at some point in their lifetime, in some place in their descendants going and hitting Notepad, then that's a detect. With timing, you might look at WinRecon tools. So here I'm saying, essentially just feed me, ipconfig, ARP route, all these guys, and I'm saying, if you see it, if you see within 10 seconds, a minimum burst of 3 of them, then generate me something.
So if you write this with not 10 seconds, but 24 hours, then the whole thing will explode, right?
It will depend. It'll depend. It'll explode if your inputs, right, the processes you're looking for, if you do like, let's say Chrome, because Chrome's already, spawning itself all the time, then you will die. But if like recon tools, I'd do it 24 hours. I think it's, yeah.
Is there any way you can put like limits on the resources any specific thing can take? So if you do make a mistake, later on you're not killing everything?
Yeah, so that's a very, very good question. The predecessor to this guy, to this DSL, had all these knobs that you could put in it that said like, after X amount of time of real time, flush the context. After X amount of time of sensor time, then all these heuristics, which really helped and allowed you to do that stuff. You could really tweak it, but I felt that it was more important for now to get it simpler and to work in, let's say, 90% of cases. And then very shortly, the feature of Beach that will essentially kind of remember which actors are there means that if you do end up killing one of your Beach nodes, it'll die, it'll respawn, and all the actors will get replaced within it. So you're not gonna go overnight, lose everything.
There's no concept of like a lifespan for an actor. So you can set like a development mode, give actors a lifespan, and then say like these are the things I want to play with for the next.
That's a very good idea. The one kind of connecting idea I've had was it would be very easy for me to essentially in Beach to register yourself in the main data feed and say, give me a sample of X, and it goes straight to your box. So you're running your actor really locally in your own process. So if it dies, it dies. But interesting point. I like that. Expiry kind of thing. And then the last one, which is, I think, quite interesting, is I'll pick this one, which is a suspected dropper hunt, which I just did now. I'm not sold on the name yet. Hunter, every company, every place has kind of different definition of all that stuff. But the idea here is I really want to go to town on this logic. I know what to do when I see something that I think is a dropper, right? A stage 0, like the demo malware. I really know what to do. It's not simple, but I know the logic. So what I want to do is I want to be able to really end-to-end automate it. So it means I want my hunter to essentially get notified on certain detections. So here I'm saying, notify me on when suspicious exec name, because that's one that I think is likely to be a dropper. When it happens, my entry point gets called with a context for my investigation. So it's an investigation context and a new message. The first detect doesn't have a message associated with it. It's a detect. What's cool is as I do the task back that we saw earlier, a tag gets associated with those messages, those tasks. And any data that comes back from the sensor is also tagged with it. So it means that magically, all the data that this hunter tasks will come back to him. So so he's able to hunt update. He'll get a context, which the hunter can put anything it wants within that context to keep some context of this hunt. And then it'll do stuff. So in this case, I'm saying if there's no new message, it's going to essentially end up tasking a whole whack of things. So here I'm saying, give me all the strings in memory of that process, try to get the file, try to get info in the file, dump the history, get all free creation, deletion, give me a snapshot of all services, drivers, and auto runs. I'm really going to town. And there, I might spike the box up for a short period of time. If that.
Agents on other boxes.
You could, absolutely. Yeah, absolutely. Because the sensor, because of the scheme of the sensor IDs, you don't even need to talk to the backend to do certain things like, essentially the sensor ID within it has the concept of an organization, subnet, and platform type. So org subnet, fairly self-descriptive. Platform type will be 64-bit Windows box or 32-bit Linux Ubuntu. And that's encoded within the sensor ID. The advantage there is we have that command line interface going through Python also has a dedicated CLI interface for an operator just hunting live. And you can also in the auto tasking add a mask to that platform and that org and that subnet. So you can say, I'm going to task all 64-bit sensors on that subnet with this thing. And then that'll get sent, that'll come back. As it comes back, what you can do is, yeah, you can look at the messages, the values coming back, but you're also able to use some internal APIs to the cloud. So all those objects, right? All the timeline, all the last events, there's tons of pivoting done in Cassandra effectively. So there's an API that grants access to that through an actor. So your hunter is able to go and say, in this case, what I'm saying is, I grabbed a snapshot, right, of services, drivers, and auto runs. I can query the model to get a diff of it. Essentially, I'm asking the model, hey, I know you received a new snapshot from the services. Do you see anything new? And the model will say, you can say in the past 30 days, the model will say, yeah, I saw, this service appear, this service disappear. And then within the last 5 seconds, I've seen this service appear. So the hunter is going to say, okay, you've seen this service appear. Well, I'm going to take it. Maybe I'm going to grab the file path, or through the model, I'm going to look at, I don't know, like the DLLs that were loaded. The imagination is your end, is the limit. And
that's a bit of a problem though, right? Because writing a useful hunt would be hard for people who are not ABT hunters.
Yeah, absolutely correct. So the spectrum of security, right? So on one hand, we have kind of the AVs, the like very, very basic security, the corporate stuff, this dude installed adware, please reimage the box. And on the other end, you have kind of the crazy APT stuff. And then even within that, you could say you have another dimension of skill set, of thoroughness, or time that you have to spend. That often it comes down to that as well. Right? This is definitely more on that end of the spectrum that says, I understand my network, I understand how to look for bad things, and I want control over it. Because yeah, you can do crazy complicated stuff. You could also do very, very basic hunts where a hunter can be scheduled. So you can say, run this hunter every hour. And that, that hunter can start and say, I'm going to get the unique, all new unique objects that I've seen in the last hour. I'm going to look for their hashes. If I haven't seen a hash, then I'm going to do a file get for one of them where I've seen it. And then for every hash, I'm going to do query and virus total. And if it's bad, then, we already have the text generated from that, but maybe if it's bad, I'm going to, get everything in the same directory, right? Because you can go really all in doesn't mean you can't go decently. So that's the whirlwind tour. of the three kind of major ways of detecting stuff. It's a lot. Yeah, I don't know if there's questions, I'd be very happy. If you need some time to digest it, just get in touch. Yeah.
So I mean, kind of what you're talking about here is the ability to build libraries, right? To do different types of detection for known.
It's the it's one of my end goals, right? Clearly one of the ideals that I have is that I can get to a point where when you get Lima Charlie, with a small community, think Yara, think Snort, right? People write detections, share it. Sometimes it works better or worse. People can increment, can work on that and try it and kind of evolve in that direction. Because of how granular they are, because of how easy they are, that's my hope, absolutely.
What if the attacker never uses malware?
That's a very good point. And that's definitely not a blind spot, but as a, I guess now old school EPP hunter, I look less at that. I think it's the new hotness of it, for good reason. I'm not saying.
Never use malware.
Pardon?
A lot of APT attackers never use malware nowadays. They just move laterally with credentials they have.
Right, but then they'll tend to lack the P part of it, right? Like it's to get persistence that it's possible, but it's tricky without malware. But no, I completely agree. It's definitely a hard problem. I think it's a hard problem for everybody, right? Just had a recent discussion about logging PowerShell execution, right? It's not easy. It's not easy for anybody. I can't do it. Like Lima Charlie cannot do it right now. The positive side of it is if you have an idea, it's pretty small. It's pretty easy to implement it. Well, for varying definitions of easy, because it is sensor development likely. But the idea is at least if you want to, let's say you want to try your hand at detecting that stuff, you can do it without having to build your own complete endpoint, monitoring the crypto, the tasking, the collection, the store. The idea is because all of this is just so modular for you to add that, you can try it on your side, and it's Apache license, so keep it for yourself and it's okay.
It's a great basic framework to get started with for doing this kind of work. Absolutely.
Experiments.
If you're worried about credentials, then you should probably be worried about how your credentials are being used in your way, right? So I don't think any kind of endpoint security can help you with any kind of network issue.
Yeah, I mean from the lateral movement point of view, like they might have the credentials, but
then you should work towards trying to detect if the credentials are being stolen or not. That's my perspective.
Or user profiling, like XLV.
yeah.
It's a difficult problem. A lot of money to be made.
The other thing is
Different tool set.
Yeah.
You need both. So what does the community look like right now for Lima Charlie? I mean, I today is my first time being exposed to the project.
Right. The project in one way or another has been in development for a while, right? Because you don't build that over 2 days. It's been open sourced since I think it was November. So the community, essentially, there's not much of a community right now, right? That's why I'm trying to get it built up, to get people to contribute, to try it, to give me feedback if anything, right? So that's kind of where it's at. It's been deployed in various instances, different components of it in the private sector. But as far as I know, there's no large deployment yet of it.
Can you say, are you guys using it here?
At Google, we are not.
Yet.
Maxime, I'm curious. I mean, from your experience, obviously for Lima Charlie it's still new, but the longer and more established a tool is, the greater the possibility of attackers creating active countermeasures.
Absolutely.
And
you're completely right. I think there's two categories that this applies to. So one of them is I'm looking for this bad technique in a specific way, which a lot of products do, right? And that is very susceptible to exactly what you're saying, right? They figure out that the way I'm looking for a process following is this, and they kind of get something that fudges it. The other bucket, which is always, it goes a bit with the philosophy, is where I want to put the most in that bucket, is the bucket of telemetry, right? So when I get file creation, when I get process creation, module lists, there's not really a technique with it, right? I'll give you a great example. Somebody may very well find a way to bypass the, let's say, the process, let's say the code injection detection in Lima Charlie, right? So they will go in LSAS and like they'll inject in LSAS, for example. And in such a way that I'm looking at the memory and they're erasing the B headers, they're faking the stack vectors, it's just, I'm not seeing it. What I may see is when I do a snapshot of the system, the processes and the modules. So here's one thing that as far as I know, every single APT has never actually tried to countermeasure, is the secondary includes, right? So I'm injecting my implant in LSAS, and I know my implant is completely invisible. Cool story. But I'm also using ADV API 32.dll, which is a legitimate signed Windows executable. There's nothing suspicious about it at all. But if now I'm looking statistically, and I see it's loaded in LSAS, that's weird. And that's where, if hunting APTs is never about getting the detect, it's always about getting that little thread, and you're like, this is weird, and you start pulling, and you start pulling, and then you holy shit. So hiding against that, they would have to now apply, apply their covert loading techniques to every dependency and every dependency of their dependency and all that, right? Which is not trivial.
Same.
Yeah, so. Is it the whole thing or just my computer? Yeah.
What about client to server ratios that you're thinking about? I know you have a sort of cloudy backend, but what are you thinking in terms of, with reasonable use, what sort of ratio are you thinking about?
That's a good question, and it's a very difficult one. If I start from, from the extreme example, right, I'm running it to keep the lights on, right? Like, I am just looking for Yarrow signatures, I'm not doing any detection in the backend, it'll take essentially nothing, right? So you do thousands and thousands of posts on a single box. What's costly is Cassandra, and don't cheap out on Cassandra, but even the ads. And the compute in particular, not so much the compute as much as the stateful compute. Stateful compute will be expensive. I try to take an order of magnitude, like as it is now with the detects that are in there, there's not a lot of stateful detection. It also depends on the retention that you set, obviously, on your objects, on your raw events, and all that stuff. Cassandra has great retention, TTL stuff. So if you keep it short, just so many parameters. It's really difficult. In my experience, even trying to plan it ahead of time is very difficult. The best way is really to a progressive rollout, and set your TTL for a week, set initial landscape, run it, see if you're good. You're still good. Okay, you can extrapolate a little bit, expand.
But there's nothing there that you'll always would warp at like 10,000 endpoints or something. There's nothing that would just like hits the wall face,
Right.
and that's it.
There shouldn't.
That's the point of Beach, right?
That's
the
why
whole benefit that you get out of Beach is that you eventually can distribute all of the compute that you're trying to do.
Yeah.
Exactly. The idea is to, at every step, always think, is this a bottleneck and does this scale horizontally?
And take that work away from the person writing the detect.
Exactly. Now, again, devil's always in the details. I'm sure if we, tried to run a Beach node with like 5 million clients coming in every 60 seconds, we would probably hit some really unexpected, I've hit Python memory allocation issues in the past. So where like garbage collection is not fast enough in certain places.
Other questions? Awesome.
Thank you, Maxime.
Thank you.
That's fantastic.
And if you have any questions, don't hesitate to get in touch. And if you'd like to try it, also don't hesitate to get in touch if you need help. I can also just spin you a note if you want to try it. I'm very helpful, hopefully.
I can attest it's very helpful.
Yeah, one quick question. Do you have any plans to create a front end for generating this Python code?
That's a good question. So the front end kind of gets you by right now. I think it'll depend on the scenarios that you want out of it, how you want to get stuff out of it. There's also what we're going to see right now, which is very, very well. I was very happy. Yeah.
So guys, I think we'll conclude at least the recording and the Hangout, folks. Thank you. And again, feel free to send questions to Maxime. Thank you, Maxime.